This is our third topic in Module 4. We're talking about water and how to measure water in the soil and on the golf course. So obviously, to keep a golf course this green, water management is pretty important. I wouldn't recommend you keep a golf course this green, but Augusta does use some of the most advanced tools for measuring moisture on the putting greens and also around the course. This is a picture taken from the 12th green. This legendarily is the very most controlled. And we're going to talk at the end about Desert Mountain, who is using some of these techniques for some very innovative stuff to track fertilizers and salts as they move through the putting green. So devices for measuring soil moisture. The first tried and true soil probe, oven, and scale. This is what we're going to do when we do gravimetric moisture content and volumetric moisture content. There's lots of other research devices. Number one is the tensiometer, a ceramic tip device that measures pressure, suction, tension. It's difficult to use. It has been used in research, probably not a tool for the golf course. I'll show you some pictures of that. Resistance block, measuring an electrical current, which measures the more water there is, the faster an electrical current goes between two probes. Also, the more salt there is. So the salt can be a tricky measurement to get moisture when you're looking for just water. A neutron probe, we'll talk about that when we get to the picture of it again. A radioactive isotope, so more research tool than a golf course tool. And then time domain refractometry, or TDR, which might have some implications on the golf course in the future. So here's a picture of a tensiometer. You can see there's a gauge. The tensiometer is filled with water and sealed. This seal has to be airtight. The probe is put down into the ground and there's a ceramic tip on that. So as the soil dries out, it creates a connection, which is shown here, a water film which pulls the water out, creating a tension that is measured by a gauge. So it's hard to get to volumetric and other by weight measurements, but we can go back and forth. So always in testing these devices for research, you're still taking measurements with the soil probe and drying them in the oven and weighing them. And it's been pretty hard to get away from that tried and true method, and that's a way that a golf course superintendent can use to see actually how much moisture is in his putting greens. The next here is a resistance block. This uses an electrical current. It measures how fast the electrical current goes through this gypsum box. Here's a more modern way. So this is buried in the soil. We put a current to that. We measure how fast the current goes between the two blocks, set at a certain distance apart, and that tells us how much moisture and salt is in there. So again, the salt is a problem with measuring this, and we need to be aware of that. Okay, I think this picture is pretty funny. Notice how far this guy is standing away from this device. I'm going to stand away from it as far as possible. It's a radioactive isotope that's put down in the ground. The isotope shoots out from the soil, bounces back, and by how much water there is, it measures, the detector measures how much isotopes are put back. Again, not something for turf grass, something I would recommend you probably stay away from, but I did use this in my research, and it is pretty consistent with some of the other measurements that we would get, particularly from weighing and using a scale. These devices, time domain refractometry, is a device that was designed for the cable companies. Actually, they can hook up this monitor here to this machine to a cable line, and it can tell you where the cable line is broken. So useful for cable companies finding breaks. But turns out that if we put these probes in the ground and run the time domain refractometry through them, it gives us a very good moisture measurement. And my friend Mike Saffel was doing some of this original research at Michigan State, and this is a device that conceivably you could put these devices in your greens and get a measurement each day of how much moisture there is and run your irrigation at a more conservative level, not erring on the overwatering, because we would have better control or better measurement of where we were at. And I would recommend probably putting 2 or 3 or 4 of these in each green, particularly at some of the wettest spots, so we would know what the moisture level is in these different areas. And this is similar to what they're doing at Desert Mountain, where they can check 3 different places across the green and actually follow the fertilizer. They're checking for soluble salts. So what you need to know, a little bit of a review, our gravimetric moisture content on a weight basis. So what this means, wet minus dry divided by dry. So we take a soil core, we weigh it, that gives us our wet weight. Then we put it in the oven, then we dry it, that gives us our dry weight. So the wet minus dry is the weight of water, H2O, and then we divide that by the dry weight, which is going to be a low number, times 100, which will give us how much moisture there is by weight. To convert that to by volume, we use the density, fact that the density of water here is 1. We take the weight basis, which say that's 10% moisture by weight, times the bulk density, which would be about 1.3, which will give us 13% moisture by volume. So the volume is going to be a little bit more than the weight, because generally the water is going to be lighter than the soil. If the soil density was 1, then the weight basis and the volume basis would be the same. So volumetric basis is in effect an adjustment for the weight of the soil. A soil depth basis is different, but also sometimes useful. Inches per feet. So if 12 inches times a percent water by volume, so if we have 12 inches times 27% volume, it would be 3.24 inches. So this would, in theory, if you had a column that was 12 inches of soil and you were able to compress the water all to one side, 3 inches of that 12 inches would be water. So just something to think about. Generally, if we were at field capacity of a perfect soil, 25% would be water. So 25% water, 25% air, 50% solids, and that's the standard perfect soil. So for your study, you're going to do, in effect, in a pot, a lysimeter study. Your pots have to be under 9,000 grams. That's because that's what our scale can weigh. But here, this researcher is out, and these are lysimeters. This is grass grown in a PVC, a big PVC cut to a certain depth, stuck in the ground. And this is a scale, a hanging scale, and he's getting a readout. So they can come measure this soil and figure out how much moisture is in there by weight. They have to do it at the end, so we're doing the same gravimetric moisture content. At the end, this whole unit here of grass and PVC will have to be put in the oven so we can completely get all the moisture out of there, and then we'll be able to know what the dry weight is. So we won't have the dry weight till the end on a lot of these types of measurements. Here's my alma mater, Michigan State, and this is a giant lysimeter. You can see they've got great big fully contained metal, and the turf is fertilized. In this case, it was fertilized with a radioactive isotope, and then they measured over years the leachate. This is the water that comes out here into these buckets to track that radioactive isotope. How much came off in clippings, how much was connected in the thatch, and how much went down into the bottom. So a huge experiment, huge lysimeters. But they also use these mini lysimeters to be able to test for the samples and to do some other stuff. So this was Dr. Eric Miltner, who did this work at Michigan State. a massive project where this was an intact soil core, so they actually lowered this lysimeter down onto that and measured the water that comes out the bottom. So, how does this relate to a golf course? There's a few different ways we can test on a golf course. Evaporation pan is always useful, just a pan of water. How much water is coming from evaporation? Doesn't take into consideration transpiration, but with tables, and agronomists have worked out amounts. So if 2 inches of water is evaporating from your pan, you might need to irrigate 3 inches to equal the transpiration rate. So this is kind of a computer model. There's some other devices to be used. You could use lysimeters. That's not an unreasonable way to do it. And then probably TDR or resistant blocks put in your green is one way that you can measure moisture and have a more accurate measurement. So avoid situations like this where we've just got irrigation problems shown there. And a place that does it the best, probably the Augusta of the Southwest. Desert Mountain has probes here, here, and here, and they can measure moisture and also salt content. So these raise very interesting data that Sean has been taking for the last couple of years at Desert Mountain, and this would be a great place for somebody to go if they want to learn about top-notch, 100% attention to detail maintenance of a golf course. This is the final par 3 of the Cochise. No, I think that's the Navajo. So there's the statue of the Navajo there, and a magnificent, almost surreal place to do an internship. So hope that helps you with some ideas on water, measuring water in the soil.